All right, guys, good evening once again. So we are back for another session. All right, so today we're going to be looking at solution to scalene triangles. And all along we have been working with right angle triangles. Now I am going to just throw the question out there to find out.
Excuse me, sir.
Yes.
Mr. Adams, just reply. He's not hearing you.
Okay, could you just advise him to just...
Good afternoon, sir.
Good afternoon, Mr. Lamar. Could you just send him a message to log back in from the, try to log in again. Just send him a message in the chat. Thanks much, Ms. Wesam. All right, so as I was saying, guys, so for the previous classes on triangle, we have been working with right angle triangles, and we touch a little bit with isosceles triangle. We are now going to be working with scalene triangles. Now, you should have been aware that we have different types of triangles. And we know isosceles, equilateral triangle. All of these are special types of triangles. Now I'm going to ask the question, anybody knows what a scalene triangle is? So somebody can just give me their view of what a scalene triangle is. Mr. Lamar, you want to try to answer that question? Ms. Cabrera, good afternoon.
Good afternoon, sir.
Good afternoon, Ms. Green. Any of you guys know what a scalene triangle is?
A triangle, sir, with 3 unequal sides.
Correct. So triangles where the sides are not all of the same length, so the sides are unequal. So we call those triangles scalene triangles. Now, whereas we were able to apply the trig ratios to right angle triangles, now for scalene triangle, applying the trig ratios might not be we may not be able to adequately apply the trig ratios unless we have a scalene triangle that you can form a right angle triangle from. In that case, we may be able to apply trig ratio. However, we will be applying what we know in terms of what we call the sine rule and the cosine rule. All right, so for scalene triangle, we'll be applying these rules. So as we move along in this topic, we will see what those rules are about. So I'm going to now just start the process of just jumping into our lesson. And so first thing I want us to recall the standard notation for triangle. Remember when we start looking at triangles, there was a special way in which we labeled triangles. All right, so just to remind you guys of how we label triangle, there's a standard way that we do so. So you would have met the labeling before, so this will be just a review for you. All right, so if we consider the triangle ABC, we see that the vertices, the point where the angles are formed, we label those with capital letters. And the side which is across from each vertex, which is the side opposite to the vertex, we label those with the common letters as the vertices, all right? So as before, you would have seen this information. So the three sides are marked A, B, C, and we labeled the vertices with capital letter A, B, C. And we oftentimes call the angles by the same name as the vertices, or as the letters of the vertices. Now we see that the common letter A would be opposite to the angle A, right? So it is right across from the angle. And remember that the angle is just simply the opening between the two lines joining at the point A. And the common letter A would be used to label the side BC, all right? And so likewise, the other common letters would do a similar thing for the other vertices. All right, guys. So just recapping, so we're just going to move along. All right, so when we're dealing with scalene triangle, guys, a second there. All right, so when we're dealing with scalene triangles, we say that these are non-right angle triangles, and we say that there are 6 elements to the triangle. All right, and the 6th element does not only apply to scalene triangle. It is also applied to right angle triangle, any triangle whatsoever. So the 6 elements would be, you have 3 sides and you would have 3 angles. So every triangle would have 3 sides and 3 interior angles. All right, so those are the 6 elements. Now, if we are going to solve non-right angle triangle, and when we're referring to solving of these triangles, we really want to be able to solve of the 6 elements. You may be given 3 elements of the 6. So you have 3 sides, you have 3 angles. So generally, if you have 3 elements of the 6, and there may be a combination of ways in which these 3 elements can appear, which we'll look at shortly. But once you have 3 elements of the 6, you should be able to use the 3 given elements to solve the other 3 elements that are not given. And so for every triangle, or in this sense of scalene triangles, we will be given 3 elements, right? Now, the elements don't mean that you have to be given 3 sides and then you have to calculate 3 angles, but that is possible. But we can have combination of how these 3 elements can be arranged. And so we're going to be looking at those. So the condition, we must have at least 3 elements. Now, a combination of 3 elements may be as follows. You can have 2 sides and an included angle. Good evening, Miss Montgomery. You could have 1 side and 2 angles. You can have 2 sides and an angle opposite to one of these sides, or you could have all 3 sides. So these are the 4 different combinations in which you can be given 3 elements. So in a question, you could be given 3 elements in any of these combinations. So you could be given 2 sides and an angle included, or in this sense, when we say an included angle, we mean an angle between the two sides that are given. We could be given one side and any two angles. We could be given two sides and one of the angles opposite to one of these sides, or we could be given all three sides. All right, so bear in mind that these are how you'll be given your triangles, and based on these combination now, we'll have to use either the sine rule or the cosine rule. So we're just going to look quickly at the sine rule. And so this is what the sine rule states. Now all right, Ms. Wilson, are you saying something?
No, sir.
Okay. All right, so this is what the sine rule is saying. Now here we have equations that relate the side of the triangle with the angle that it is opposite to. So if you find the side A over the sine of the angle A, it would be equal to the side B over the sine of the angle B, which is equal to the side C over the sine of the angle C. So this is what we refer to as the sine rule. Now, with the sine rule, based on the combinations that we are given, we may not need to equate all of these three ratios. So oftentimes when we're using the sine rule, we will only choose two ratios based on what sides we are finding. So suppose we are trying to find, suppose we have the angle A and the angle B and the side B, and we want to find the side A, then we would only just choose this part of the equation when we are using the sine rule. So it is based on what angles they are given and what side they are given and what side they are trying to find. So that's how we use it. So when we're looking at some example, you'll have a better understanding of how to do that. All right, so this is the sine rule. Now the question will be, when do we apply the sine rule? Now the sine rule may be used when, one, when you're given one side and any two angles. So let's say you're given a situation where you have the angle theta, you have the angle alpha, and you're given one side. Now, it doesn't have to look exactly like this in terms of the side given. You could be, instead of given the side A, you could given any one of the other sides that are not given. But the key thing, you're only given one side, so you could be given B or you could be given C with two angles. Now, the other condition for the sine rule is if you are given two sides and an angle opposite to one of the sides, right? So you notice here, you would have B, which is one side, and you have A, which is the other side, and you have one angle, which is alpha. But you have one of these sides opposite to alpha. In this case, the side B is opposite to alpha. So this would be the condition under which you use sine rule. So these two conditions only apply when you're using the sine rule. Now, if you notice, when we were referring to the combinations in which we can be given 3 elements, I've listed 4 combinations. Now, of the 4 combinations, 2 of the combinations are used with the sine rule, and the other 2 combinations are used with the cosine rule, right? So these 2 combinations, you are used with the sine rule. So you have to pay attention to which combination you have in order to determine which of the rules to use, whether you're going to use the sine rule or the cosine rule. So it's only when you have these 2 conditions here, you can apply the sine rule. All right, is that clear to everybody? Raise your hand. Let me see if you're following me so far. Any question, guys? All right, Ms. Wasom is following. Anybody else is following? Ms. Guevara, are you understanding what I'm saying? Are you following? Ms. Montgomery? Ms. Green is understanding. Ms. Montgomery, how about you? Are you following me so far?
I'm following, but I don't understand.
All right, so we are just giving some rules and we are showing you the conditions when we use the rules. We have not yet used the rules. You will see how those are used when we are doing some examples. But what you need to know now is what condition you have to have when you're applying the sine rule. So we are saying this equation that we give you, sine A over sine A equal B over sine B equals C over sine C. That is the sine rule. And we have listed 2 conditions here. One condition is when you have one side and 2 angles. So if you're given a triangle where you have one of the side and 2 angles, you can use the sine rule. The next condition is that you are given 2 sides and one of the angle, which is opposite to one of the sides. So the second condition also will be applied when you're doing the sine rule. So these are the 2 conditions that are applied when you're doing the sine rule. So if you're given triangles that resemble these, then the rule that you want to use is the sine rule, which you have not yet learned how to use, but you have to know when to use them. And this is telling you when you're going to need the sine rule. So once you see your triangles looking at these, that's when you need your sine rule. Are you following, Ms. Montgomery?
Yes, sir.
Is that clear now?
Yes, sir.
Okay, good. All right, so these are the 2 conditions for sine rule. Now we have mentioned the cosine rule. And so the cosine rule, this is what the cosine rule looks like. The cosine rule is in the form of 3 different equations. Now, we're going to take a little time to learn these equations because it is important that we know them based on the angles and based on the side. So don't worry your head about how they look just now. We will go through them together and you will take the time out to learn them, all right? So these are the sine rules. So the sine rule comes in 3 parts. So if you know the following conditions that I'm going to put up, you can use any of these rules. So the conditions for the cosine rule. So the cosine rule may be used when, first condition, when you have 2 sides and an angle between the 2 given sides. And this is what it looks like. So here you're given the side A, you're given the side B, and between those 2 sides, you have the angle alpha, all right? And so once you have this condition, you can apply the cosine rule. All right, is that clear with everybody? Now the next condition is that if you are given all 3 sides, with no angle. You can also use the cosine rule. So the conditions for the cosine rule would be given two sides and an angle between, that's one condition, or you may be given all three sides. Now, if you can remember these conditions, then you will know once you see these conditions, you are to use the cosine rule. Is that clear to everyone? So my question is, does anyone know able to tell which condition to use with the sine rule as opposed to the cosine rule? Do you think you will be able to remember that? It may not be readily absorbed in your brain, but as we do some examples, it will become clearer to you, all right? All right, so let us move along, and we're going to look at a little proof for the cosine rule, because we saw the rule, and what the rule states is that the sine of you start off with the sides. So if you have the side A over the sine of the angle A, it is also equal to the side B over the sine of the angle B, and the side C over the sine of the angle C. So we want to see why this rule can be used, or we want to prove that the rule really works. So I'm just going to walk you through how the rule came about, but you are not required to be able to show how the rule came about, or you are not required to be able to prove the sine rule. All you're required to do is to be able to use it, all right? So what I'm doing now, you don't have to be able to do it. All right, so if you look at this triangle, you notice that we have kind of a compound situation. We have two right angle triangles join at the point A. So we have that vertical line coming down from A to D, all right? But when we merge the two right angle triangles together, overall, it gives you what we have as a scalene triangle. So I don't want you to focus too heavily on the right angle triangle part of it, but I want you to focus more on the scalene triangle. Now we're going to use the right angle triangles, however, to show you why these equations work. All right, so in the triangle ABD, and let me identify that triangle for you. So we are looking at the triangle going from A to B, and then we go to D, going back to A. So that's a triangle that we're referring to. All right, now if you look closely at that triangle, if we apply the trig ratio of sine, the sine ratio, the one that we already know how to do, we would see that the side C would be the hypotenuse, and the side AD would be the side opposite, right? So if we are going to calculate AD, if we are writing the sine ratio in relation to AD, generally we would say the sine of angle B, because we are working with angle B now. So we'll say the sine of angle B is equal to the side opposite. In this case, it would be AD over the hypotenuse, which is actually C. And if we are making AD the subject, it means that we would cross and multiply the sine B. So we would have C sine B is equal to AD. All right, everybody agree with that? And so if we flip it around, we can say AD is equal to C sine B. Sine B rather. All right, so everybody should see that because we have been working with these trig ratios for a while. All right. All right, so if everybody see that, then you should be able to appreciate how we come to AD, how we get this. You should be able to appreciate that. All right. Everybody see how we get this? AD equal to C sine B. Is that clear to everyone? Raise your hand for me, please, if you are clear on that. All right, Miss Waysome sees it. It's a Lamar, Miss Green sees it. Anybody else see how we get AD to be equal to C sine B? It is based on what I've just done when I write out the ratio, because I say the sine of the angle B is equal to the opposite over the hypotenuse, and then now we would get to what? So going back to it one more time for you, we are saying the sine of B, which is the angle B, so we're using the capital letter, equal the opposite side to B. So this side AD is opposite to the angle B because it is in front of the opening of the angle. So we put that side AD over the hypotenuse. As remember, the sine is opposite over hypotenuse. Now, in this case, the hypotenuse is C. Now, in order to calculate AD, if you are dividing on the right-hand side by C, we move it across to the other side and multiply by what we have on the other side. So we move the C across to this side and times it by. So this would become, so remember there's an invisible multiplication sign between here. So C sine B would be equal to AD.